Hello, I'm going to show how to compile Python 3, the latest version, from the source code and to install it on Ubuntu Linux. But first of all, let's think, why would we want to do that? Surely every Linux distribution, and this one happens to be Ubuntu 22.04.4, comes with Python 3 pre-installed. But I can think of the following three reasons. First of all, let's have a look. What's installed here? The default Python 3 is in user bin, as you would expect. Now, if we run it, we can see it's version 3.10.12, which is reasonably recent. But if we go to python.org, we can see the latest version is Python 3.12.3. So that's one reason. Let's say we want to run a different version. The second reason actually is very weak because there is a workaround. It's about packages. Let's say you want to use different versions of some packages than the ones that are bundled with the distribution. For example, if we look at matplotlib, you can see that the package, like an application package, Python 3-matplotlib, comes with 3.5.1 matplotlib. But the version that I installed with 3.12 is I believe currently the latest, which is 3.8.4. But as I said, this is a very weak reason because you can use virtual environment in the old Python as long as it's compatible with the latest version of the package you want to install, and install it there. So it's not a big deal. A much more important reason, number 3, is let's say you want to compile your Python differently. So I'll show you how to find out how the binary was compiled, how the Ubuntu binary was compiled. So let's go ahead. The first step is you go to download section, you click on this source, and you download it. I've already downloaded it to downloads directory, so I don't need to do it again. So you download it, then you go to that directory and you extract it. You extract this archive, you get a directory, you cd to that directory. So this is the source code. This is the full source code of Python. This is C Python. So it's a standard Python written in C. So before we compile it, well, obviously you know how you need to configure it, but don't rush to configure it. Let's study which options we have. You could study them using --help, but I don't recommend this way because some options are actually missing here. A better way is to go to the python.org website, go to Python docs, and here you just search for configure Python, and you get just make sure that documentation you're reading is for the latest version. Get rid of this yellow stuff. Okay, so this is a much more reliable documentation. Why? For example, this option --disable IPv6, it's not even mentioned. If you look at for IPv6, you can see enable IPv6 is mentioned, but disable is not. So anyway. So now, how do we configure? Before we start configuring it, I want to tell you that you need to install some packages. I recorded the list of them here. These are just development packages of some libraries, which you need to have installed before you build your Python. Otherwise, some modules will be missing, like SQLite 3, etc., like zip2. So in my case, they are already installed. So if I try to install them again, then I'll just get a message that they are the newest version. Now, one thing, by the way, as I said that it doesn't matter where you download it, but strictly speaking, if we are pedantic, it actually does matter, although you will delete this directory after compilation. But just be aware that the full path of your directory where you build it is hard-coded in the final binary. So for example, this is the binary in user local bin that I built previously, and we can see it has the word Tigran in it. So it has this is where the directory path where I built it previously. So just be aware. Now, how do we find out which configuration options to pass? First of all, we can use sysconfig module to find out how Ubuntu binary was compiled. If you just use sysconfig, you get a lot of very interesting stuff, but we don't need all of it. All we need is config args. So we get config args, we get all these options. So this immediately shows us, confirms us in our desire to compile our own. Because, for example, enable shared. We definitely don't want our Python to be compiled with enable shared. It makes it slower. Some benchmarks show between 8.9% to 30%. Well, at least some previous versions. I'm not sure about 3.12, but in some previous 3.x versions, it was a huge performance degradation. Now, but why would you need it at all? This is for being able to embed Python in applications. So normally you would actually build it twice. First to build the shared libraries, and the second time without enable shared to build a proper fast binary. But because I don't need to compile applications which embed Python interpreter, so I will not pass this option at all. The second thing is enable IPv6. We want the opposite. We want disable IPv6. I remember in 1981, supposedly Bill Gates said this 640K of memory ought to be enough for anybody. Well, we don't know if he really said that, but in any case, he was wrong. Well, if he did say that. He was wrong, because surely we use computers with more than 640K, and they are very useful. However, it is true to say that 4.2 billion public IP addresses really ought to be enough for the whole planet for ages to come. And I'm not saying that there won't ever be more than 4.2 billion computers on the internet. No. You have to remember about the private network addresses, private IP addresses, the class A, class B, class C. So because they are duplicated, you can have many more instances of IP addresses than 4.2 billion. So yes, so IPv4, in any case, you can have a look at my interfaces. None of them have IPv6. I even disable it on syscontrol level, on kernel level here. I pass this option to disable it in the kernel. So we definitely want disable IPv6. So let's prepare configure disable IPv6. Now, enable loadable SQLite extension. Yes, we definitely want that. If we don't pass that, then our SQLite 3 module won't be able to load extensions. For example, most important, FTS3. Yeah, full text search. You would be missing that, and that would be horrible. So yeah, we definitely need this option. Another option that I recommend is if you scroll down to performance optimizations. Yes, enable optimizations. I recommend that. It's safe, the POGO optimizations. It is safe. It increases compilation time a little bit. Well, quite a bit. Because if you enable optimizations, it's quite logical. If you enable optimizations, then you need to run all the tests. So the tests will be enabled, and you just have to wait for the tests to complete, but that's okay because it only takes a few minutes. There is another one, minus minus with LTO, but that one is a bit more dangerous, and especially enable bold. It's a bit more dangerous because if, well, first of all, it makes the compilation, or not compilation, the linking time much slower, but that's no big deal, we can wait. But the problem is then during the tests, it emits various dangerous warnings, so it's not, I don't know, I don't risk it. So I just go with minus minus enable optimizations. What else do we need? Now let's have a look. We definitely don't want dtrace, this one, dtrace. I don't want system tab, dtrace. It makes things a little bit slower. Well, it makes things, in any case, it makes executable code bigger. And we don't want bigger code. That means less efficient CPU caches. So well, if you do use dtrace, then by all means, but I don't want it in my Python. This with systemxpath and systemmp-decimal libraries, again, I can understand why Ubuntu binary is compiled with these options, because they control which versions of these libraries are shipped and they match Python against them. That's okay. But in my case, I don't want to keep track of those versions and then have to recompile Python every time. No, I would rather have Python use those libraries, those versions which are included in the Python distribution. So, you know, they are automatically matched, they are automatically correct. So that's it. That's what we pass. Disable IPv6, enable SQLite extensions, and enable optimizations. That should be enough. So we just configure it. Now, configuration is very quick. It's just I want to point your attention to one thing here at the very end. At the very end, it will show you about the standard modules. Let's make the terminal a bit longer, like this. Yes. Okay, so here, just make sure that all these stdlib extension modules, that they are all yes. The only one that is okay to have missing, this one, DBM, well, I have GNU DBM, so I don't need DBM, so that's okay. This one is missing, that's no problem. So the next thing is we compile. How do we compile? Well, we have to check how many processors we have. We have 8 processors, so we can, well, in my case, if we run htop, we'll see that all 8 processors are actually very, very busy, because you can see FFmpeg at 4K resolution, 25 FPS. I'm encoding this screen, capturing this screen, so I'm, you know, the machine is very busy. But in any case, we started with -J8 because we are not going to watch the paint dry. I'm going to stop. It finished compiling. Don't look at the time, it finished compiling ages ago. I just went away for a few minutes. It actually compiled at 21:14. Okay, so now we can just install it. Sudo make install. So now, after the installation, we still need to do one little thing to clean up. Because as you can see, it all goes into user local lib and user local bin. So binaries went into user local bin and all the packages in user local lib. Now, what we need to tidy up is in user local bin, you know, the usual stuff like Python 3, pydoc, Python 3 config. They all now point as symlinks to the new version, to 3.12. But we don't want that, because obviously user local bin in our environment, in our path environment, is before user bin. So the system Python 3 would be shadowed. It would not be executed. It would execute 3.12. But we don't want that to happen. So we want to remove these symlinks. So if you, these are just symlinks, so the binary of course is still there. So if you want to run Python 3.10, you just run Python 3. If you want to run 3.12, then you run 3.12, and you run the latest one that we've just compiled. Now you don't need to reinstall all the modules. All the modules that I installed previously, of course, they are still there. You don't need to reinstall them because we didn't do a major upgrade. If we switched from 3.12 to 3.13, still theoretically we wouldn't need that, but it would be probably better to reinstall. Okay, so that's it. We are finished. By the way, IPython points to 3.12. Yes, that's good, because that's the IPython module that I installed for 3.12, so it picks up that automatically, and it lives in my .local. Yes, so when you run, you install packages with pips 3.12, they go into .local. So they go to .local lib Python, and correspondingly the binaries go in here. Things like Jupyter, IPython, etc. They all go in there. Cython. So that's it. And